Welcome back to Daily AI News at Let's Data Science. It's 2026 0410. Today we're diving into some pivotal developments from the future of machine intelligence to major product launches. Let's get to it. We begin with a critical security revelation affecting the very foundation of today's AI deployments. Researchers have exposed a one line jailbreak technique called sock puppeting that successfully bypasses safety guardrails in 11 major production large language models. The affected systems include OpenAI's ChatGPT, Anthropic's Claude, and Google's Gemini. What makes sock puppeting particularly alarming is its simplicity. Unlike earlier jailbreaks that relied on long, carefully engineered prompts or compute intensive optimization loops, this exploit uses a single API conformant input. It manipulates how models interpret instruction hierarchy and message roles, specifically the assistant, system, and user roles that many SDKs expose by default. In practical terms, the attack abuses standard message handling semantics. By crafting one line of input that reinterprets role priority, an attacker can cause the model to ignore embedded safety policies and generate malicious or disallowed outputs. No complex gradient tricks, no adversarial search, just a cleverly structured API call. For practitioners, this reframes the threat model. The vulnerability isn't just in prompt engineering, it's in API surface design. The researchers recommend concrete mitigations: validate and canonicalize incoming message role fields, disallow unexpected role transitions, enforce server side content filtering rather than relying solely on in model refusals, and harden tool and function call outputs so they cannot be reinterpreted as higher priority instructions. This is a wake up call for anyone deploying LLM backed applications. If your system forwards user provided content directly into a model context without strict role validation, you may already be exposed. Expect OpenAI, Anthropic, Google, and other platform operators to issue SDK updates and tighten message validation schemas in the near term. In the meantime, assume hostile inputs and design accordingly. Next, let's zoom out to the hardware layer powering this AI boom. Taiwan Semiconductor Manufacturing Company, better known as TSMC, has posted record first quarter revenue of $19.113 trillion, or about $35.6 billion. That's a 35% year over year increase. March alone reached $415.2 billion, up 45.2% from a year earlier. The primary driver, sustained demand for advanced AI chips from customers including NVIDIA and Apple. TSMC is one of the few foundries capable of producing leading-edge logic at the nodes required for modern AI accelerators. As AI data center demand absorbs advanced node and packaging capacity, TSMC has raised prices on its most advanced processes, boosting revenue per wafer and supporting margins. This reinforces TSMC's strategic position as the linchpin of AI infrastructure. When hyperscalers order GPUs and custom accelerators, they are effectively booking time on TSMC's most advanced production lines. Analysts from SemiAnalysis, including Shravan Kundojala, suggest TSMC may exceed its 30% annual growth target, underscoring how deeply AI spending is reshaping semiconductor revenue mix. For engineers and infrastructure planners, the takeaway is clear: leading-edge capacity remains constrained and expensive. Watch TSMC's CapEx guidance and gross margin disclosures closely. Also monitor upstream suppliers like ASML, whose lithography systems are essential for these advanced nodes. Geopolitical supply chain risks and softer smartphone and PC markets remain variables, but AI demand is currently offsetting those weaknesses. From chips on Earth to compute in orbit, an intriguing new Arxiv paper proposes a radically different approach to AI infrastructure. Titled Reduced Mass Orbital AI Inference via Integrated Solar, Compute, and Radiator Panels, the paper outlines a distributed architecture for sun-synchronous orbit satellites that integrates solar cells, radiator surfaces, and compute into thin, modular panels. The design claims more than 100 kilowatts of compute per launched metric ton, with a specific power near 500 watts per kilogram. For context, conventional spacecraft often operate below 100 watts per kilogram. The key innovation is thermal. Large vapor chamber radiators are built directly into each panel, maintaining integrated circuit junction temperatures near 40 degrees Celsius to improve efficiency and reliability. A reference configuration describes a 16 megawatt satellite weighing 150 tons. composed of 16,000 panels arranged in a 20-meter by 2,200-meter grid, sized to fit within a single Starship payload. A 1 kilowatt per panel subarray of 512 panels could run an inference-only large language model with a 500,000 token context window and 128 attention blocks at 553 tokens per second per session across 256 simultaneous sessions. Scale that to the full satellite, and you're looking at more than 7,900 concurrent inferences. This is still theoretical, and major engineering challenges remain. Radiation-hardened custom integrated circuits, high-bandwidth inter-panel links, and large-scale vapor chamber validation. But it reframes the economics of on-orbit inference. Instead of downlinking massive datasets to Earth, compute could occur directly in space, optimized for long-context LLM workloads. For those thinking about edge inference, thermal-aware hardware, and launch-constrained economics, this is a blueprint worth studying. Now let's turn to the enterprise layer. At its APAC Analysts Insights event in Bangalore, IBM positioned itself at the intersection of digital sovereignty, agentic AI, and cybersecurity. The company introduced Sovereign Core as its response to rising global requirements around data locality, key management, and regulatory compliance. IBM argues that digital sovereignty is no longer just a European regulatory concern. It's a global strategic imperative. Sovereign Core is designed to give enterprises and governments control over where data and models run across on-premises, private cloud, and public cloud environments. It emphasizes cryptographic key governance, operator authentication, audit-ready evidence generation, and agent orchestration with enforced guardrails and human-in-the-loop checkpoints. The message is clear. As agentic AI systems shift from generating text to taking actions, CIO priorities move from delivery speed to governance and accountability. IBM is betting that regulated industries will favor integrated stacks that bundle model orchestration, security controls, and compliance tooling into a coherent platform, even at the cost of greater vendor lock-in. For architects building in finance, healthcare, or government sectors, features like immutable audit trails, explainable decision checkpoints, and verifiable isolation are rapidly becoming procurement requirements, not optional add-ons. Now, for a few other key updates in our lightning round. Microsoft Azure is expanding its generative AI scope across the spectrum, from large language models to advanced multi-agent systems. Through tools like Azure AI Foundry, the Microsoft Agent Framework, and Azure Machine Learning's generative AI capabilities, the platform is positioning itself as a unified environment for both single-model deployments and orchestrated multi-agent workflows. In financial automation, an author documented giving 4 AI agents access to a corporate bank account via a multi-agent control room. Every action was governed by Open Policy Agent, or OPA, policies to prevent unauthorized fund transfers. It's a practical demonstration of identity-driven guardrails for money-moving agents, an increasingly relevant use case. On the infrastructure front, Lumentum reports that hyperscaler demand for its optical components has filled its order book through 2028. The company is accelerating capacity via brownfield expansions to meet AI data center demand for high-speed optical interconnects. Expect continued supply pressure and extended lead times for lasers and transceivers. Tata Consultancy Services, or TCS, posted modest profit growth aided by rupee depreciation, but is reinvesting gains into AI hiring and partnerships. With roughly $1 billion earmarked for capability building and alliances with OpenAI and major hyperscalers, TCS is executing a build, partner, acquire strategy. Talent sourcing programs like CodeVita and HackQuest reflect a shift towards skill-based recruitment in AI and cybersecurity. Finally, a new Arcsave paper proposes a universal foundation model for protein dynamics using a multi-chain tree-structured framework with transformer propagators. The goal is to model interchain interactions and temporal propagation across diverse protein systems, potentially laying groundwork for foundation-scale models in computational biology. And that's your AI briefing for today. The landscape is moving faster than ever, and we'll be here to track it with you. For more insights, visit us at letsdatascience.com. Thanks for tuning in. Stay curious, and we'll be back tomorrow with the latest in AI.